Today we're going to talk about chapter 5. So chapter 5, there's a lot of sections in chapter 5, but we're only going to cover the first 4. Iterators and array list is actually something that we'll talk about array list maybe like toward the end of the chapter or toward the end of the class, but not really like I won't give you any I'm not going to require you to know it for your exam, right? Hey, can you guys be quiet, please? Yeah. All right. So it's something I'm not going to ask you on your final exam. All right. But it's something that I'll probably just go over if we have enough time to talk about it. You will talk about it in Java 2. So really, there's only 4 sections to talk about in chapter 5. If you're following along in the book, we're going to talk about the Boolean expressions, the if statement, and then there's a section on comparing data, which has to deal with like how you actually compare data, if it's a primitive data type or if it's an object, and that's where the equals method comes into play, and then the while statement. And then in chapter 6, we'll continue with the for loop, the do loop, and the switch statement. All right, does anybody have any questions before we start? All right, so flow of control, so you'll hear this term kind of thrown around, but basically it's just the way your program flows. So previously we were writing things linearly, meaning every statement would just execute, right? Like your program just goes down the line and executes every single statement. But now that we're using if statements, we can actually control the order in which statements are executed, right? Depending on some specific condition. All right, so I'm just going to go ahead and read the slide. So it says, unless specified otherwise, the order of statement execution through a method is linear, one after another. Some programming statements allow us to make decisions and perform repetitions. These decisions are based on Boolean expressions, also called conditions, that evaluate to true or false. The order of statement execution is called the flow of control. Conditional statements. A conditional statement lets us choose which statement will be executed next. They are sometimes called selection statements. The conditional statement gives us the power to make a basic decision. The Java conditional statements are the if and if-else statement and the switch statement. Okay, so there's only 2 conditionals in Java, which is the if, and then you can attach an else to that, or an else if, and then you have the switch statement. We explore the switch statement more in chapter 6. Okay, so here are the Boolean expressions. I talked about this. I'm going to just read through the slide. A condition often uses one of the following equality operators or relational operators, which return Boolean results. So you have the equals to, which is just a double equal sign. So single equal sign, it says it down here, right? You have to be careful with these two, right? A single one is the assignment operator. That's when you're actually assigning a value to a variable. But the double equal sign is the equality operator. So it's going to check if one, like something's equal to the other, right? It's going to return a Boolean expression, or the result is going to be a Boolean expression, right? So like a true or false. You have the not equals, which is just the exclamation mark and the equal sign. You have the less than, greater than, less than equals to, and the greater than equals to. Okay, so the thing that throws students off is the difference between the two, right? So double equal sign is the equality operator, and the single equal sign is the assignment operator. An if statement with its, okay, here's Boolean expressions. Okay, so an if statement with its Boolean condition, and it has if, and then the condition is if sum is greater than max. If it's true, then the statement will be executed. Okay, pretty simple, but they just talk about it here. Okay, so first the condition is evaluated. The value of sum is either greater than the value of max or it is not. If the condition is true, the assignment statement is executed. If it isn't, it's skipped, right? So basically, if this evaluates to being true, then this statement will be executed. See age.java. I'm going to skip that. You guys can look through that later if you need more examples. Okay, so the logical operators. So Boolean expressions can also use the following logical operators. You have the logical not, you have the and you have the or. They all take Boolean operands and produce Boolean results. The logical not is a unary operator. It operates on one operand, while the logical and the logical or are binary operands, or binary operators which operate on two operands. Okay, so the not, you could just apply it to, it just gets applied to one thing, right? Where the and the or, you need two, right? Like you need like some expression over here, some expression over here. If they're both true or one's true, not the other, then the whole result is going to be true or false. Yes.
What is XOR?
XOR. Oh, we don't, or I don't know if we have that in Java. Yeah. I'm not sure because I know they've changed they've added things in with some of the updates, but I don't think they have it. But normally it would be the up caret on different programming languages, right? But I don't think we have XOR. Yeah, so we'll stop talking about that just because I don't want to confuse anybody. But yeah, for now, let's just know that it does not exist. But I'm gonna have to like Google that and see if it is actually applicable. So we have the not, the and the or. There is no other logical operator as of now. Okay. All right, so here is the truth table using the logical not. So the logical not operation is also called logical negation or logical complement. If some Boolean condition is true, then the using the logical not on that condition is false. So if A is false, then not A is true. The logical expression as shown in the truth table. So if A is true, then not A is false. If A is false, then not A is true, right? It just gives the opposite of what it is. The logical and expression, so we have the expression A and B, so they both have to be true for the entire thing to be true. The logical or, we have the expression A or B. Either one are true, then the entire thing is evaluated to be true. And then they give you a truth table right here. So the truth table shows all possible true or false value combinations of the terms. Since the and the or each have two operands, here are the four possible combinations of A and B. So if A is true, B is true, then the A and B is true, and the A or B is true. Okay, but notice that these being true here sets this to be true, but that's the only time that A and B is ever true, right? Everything else is false, because if A is true and B is false, A and B is false. If A is false, B is true, A and B is false. If A is false, B is false, then A and B is false, right? Because they both, the and basically says both conditions must be true for the entire thing to be true, right? Where the or is a little different, right? So if anyone, the way the or works is if A or B is true, then the whole thing is true, right? So if A is true and B is true, A or B is true. If A is true and B is false, then A or B is true. If A is false and B is true, then A or B is true. And then if A is false and B is false, then A or B is false. Okay? So it's true for almost everything except when they were both false, right? Where the and is, it was only true for when both A and B were true. That makes sense? All right, so expressions that use logical operators can form complex conditions. So here's I guess they consider this a complex condition, right? Because you can use the and. So they're saying if total is less than max plus 5 and this Boolean is false, right? Because that it's like just saying that this is the not, so it's gonna, if this is true, then the not would be false. So this has to be false in order for this to be true. Does that make sense? I don't know. Yeah, I know it seems kind of complicated, but if this is false, then not found would be true, right? And then total would have to be less than max plus 5. All right, so all logical operators have a lower precedent than the relational operators. The not operator has a higher precedence than the and the or. Okay, so right here they're talking about the order of operations inside of this evaluation. Okay, so this is going to be evaluated before this is checked. All right, does it make sense? Like this is a like if you check this first, total less than max, and then try to add 5 to that, the result of that is a Boolean. Like it wouldn't even compile. Okay, so the +5 is evaluated before this comparison is used. Okay, but this takes precedence before anything else, right? So you're just basically knotting whatever is here. Okay, so it's doing this evaluation, then doing this, and then that, and then it's doing the end. Actually, I said that backwards, right? Because it's in the order in which it occurs from left to right. So it's gonna like sum up that, right? And then it's gonna check this, okay? And then it's gonna come over here. If this actually returns false, then this won't even happen, because it's gonna look at that and say, okay, well, as soon as if this is false, there's no need for me to check if this is gonna be true, right? It just sees this as being false, and then it will just ignore what's over here. But this came out to true, then it's gonna see this and say, okay, well then this has to be true, and it will check to see if found is false. Okay. All right, and then they give you a truth table to what we just looked at. So if total is less than max, and you have found, and then it gives you what not found is, and it's telling you how this would evaluate, right? So because it's the and, right, they both have to be true, meaning this has to be true, and this has to be true. So the only time it's actually true is right here, right? So if total is less than max is true, and the Boolean found is false, then not found would be true. So then it would make this true and this true. So that's the only, what's highlighted is the only time that that expression would evaluate to being true. Any questions on that? All right, so the next thing is, this is exactly what I was just talking about. The whole thing with the short circuit, where you don't even evaluate something unless you need to. Okay, so the processing of the and or is what we call a short circuited. If the left operand is sufficient to determine the result, the right operand is not evaluated. So here is your and. Okay, so what they're saying is just check here. If that returns false, then Java won't even bother looking at this side of it, because it already knows both have to be true in order for the entire thing to be true. So why am I going to waste processing time and check that other side, right? It immediately knows, like, hey, it's false, I don't need to check the other side, and then it just prints this out. Okay. So this type of processing should be used carefully. I guess it just wants you to know, like, you need to be careful with it, just because you need to understand that something might not actually trigger. Let me see if I should probably demo this somehow. Let me think about how I'm going to do this. I guess I can use a null pointer exception. All right, I'm going to try to demo this really quick. So I'm going to hop over to Notepad, and I'm going to close all this stuff. All right, I'm going to save this, and I'm going to call this one short. Circuit.java. Okay, so I'm going to do public. It's not public. Public class and public static void main.
You did that on purpose.
I didn't do that on purpose. All right, public static void main, and how am I gonna, man, I can't think of a way. All right, so the first thing I want to do, I'm just gonna like make some number, like let's say like num1, and for now I'll just say it's 0, and then I'm gonna have some condition where I'd say like name, Okay. I'm say name is, and for now, I'll just say like, I don't know, say Mike. All right. I'm gonna have some condition here. I'm gonna say, okay, well, if num1 is less than 10, I'm gonna do something, and then I'm gonna say if your name dot let's see. Oh yeah, this will work. Name. So name's a string, right? Everybody agree with that? So I'm gonna say name dot length is greater than 5, which it won't be. No, wait, that's not gonna work. I thought it would work. Less than 5. But if I do like char at 5, okay, I'll say like char at 5 is equal to. Oh yeah, I did. All right. So if those two things happen, if num1 is less than 10 and char at index 5 is an H, a capital H, then I'm going to print something out, okay? And then the else case would be like the condition wasn't met. I'll just say like system.out.println, I don't know, false. I have no idea. Like maybe like I'd say like num is less than 10 or H is at index 5. I'll say like num is less than 10 or name or char at index 5 is H. Oh wait, this is the not though. So is not less than 5 and char at index 5 is not H. All right. Okay, but over here, if it does happen, then I would just say the condition is true. All right, so let's look at what's happening here. Okay, so I have this complex condition where I'm using an AND. I'm trying to show you guys short circuit. So I want to show you if this is false, it's not even going to check this over here. Okay. Now what I did here purposely is I'm looking at char at 5. This is going to throw an exception if my name is not long enough, right? So my name is Mike. So I have a character at index 0, at index 1, index 2, and index 3, right? So I still need like 2 more characters to even get to index 5, right? So when it does this here, it's going to throw an exception. All right, so if I were to compile this and I was to run, you can see that it did not run, right? You got a runtime error, and it's just saying like string index is out of range. Okay, now to prove that it short circuits, meaning they won't even bother checking this, is if I make my number 100, which is not less than 10, I compile and I can run, then you can see that it actually did not crash, right? It didn't actually get to this point because it just ignored it. It said, okay, well, since this is false, I already know enough information to fail this entire expression. Right? Does that make sense? So it didn't even bother to check what happened over here, and it just printed out that line, right? So that's an example of the AND short circuit. The example of an OR short circuit, I'll just say, okay, well, if num1, actually let's do a different number. I'm going to go make a new number. That way I can just leave num1 the same and I don't have to worry about it. I'll say if num1 divided by 2 and the remainder of that is equal to 0, meaning you can divide it by 2 and it's even, or I just use the same thing, the same check. Or the name at char 5 is equal to H. Then I'll print something out. The condition with the or is true. And then up here I put the condition with the and is true. All right, and then I'll just copy what I did here. And man, I said a bunch of stuff. I should just say like the condition with the or is false, right? All right, and okay, so the way the or works is it's not going to short circuit on false, it's going to short circuit on true, right? So if num2 is even, this is going to make it true, and it's not even going to bother checking what's over here. If this is false, then it will crash, okay? So I'm going to come over here, and I'm going to make a num2. I'm going to say num2 is 13, which is not even. So that means that when it gets over here, this is going to return false, and this is going to move over here to check to see if char 5 is H. I'm going to go and just change this to like char 7 is P. When I compile and I run, you can see that the first condition, right, failed, and I outputted the false, okay? With the second condition, it said array index is out of bounds at 7 because it evaluated this part here, okay, as being false. So then it moved over here to check to see if this was true. If this is true, then it would have made the whole thing true, and it would have printed out that. Now I can short circuit this by getting the first part right, by just saying, okay, well now I'll make it 12. It's even now, so when you do divide it by 2, the remainder will be 0. And then Java's going to see this as true, and see you're using the or case and say, you know what, I have enough information to make this entire expression true. So then it does the system out print line. So I'm going to compile and then run, and you can see that it didn't crash this time because this was completely ignored. All right, does that make sense? Like that's a short circuit. I didn't even bother checking that second part of that condition. All right. Okay, so just keep that in mind. It's actually used a lot, right? Especially in Java, because Java has. So in Java, objects can be null, right? So a lot of time when you're doing comparisons with objects, you're going to call the equals method. So if you try to invoke the equals method on an object that is null, it's going to crash, right? So one of the first things you're going to do is check to see if the object is null. If the object is equal to null, then you're just going to like not do the second part of the condition, right? Like you won't even invoke the equals method. So another thing would like so just for instance, like you had a name, and then you had your name and you wanted to compare it to a name that was coming in from the user, right? You have the user enter a name, but say for some reason he somehow like it came. Sometimes it would come in as null. What you can do is check to see if that name coming in is null, right? If it is null, then you won't even bother like coming to this part where you're gonna invoke the equals method on that object, because if you did, then the object would you would have a runtime error because the object's null and the program would crash. Does that make sense? Right? So I could, the best thing to do would, I don't even know why I thought of this, right? But I should have thought of this before I gave this example. But a better example of this would be if I were to just copy, I'm going to copy this one more time. I'm going to leave what I have and just say, I first check the name length here, right? If the name length is greater than 10, right? Then I know that I'll have an index here at 10 because the length would be, you would have a 9, right? The highest index would be a 9. All right. And then you can say, okay, well, if there is I don't know, a space there. No, let's do something. Let's just say if there's like a W right there on the ninth character in the name is a W, then you can say the ninth char in your name is W. Okay, and then the else or here would be you don't have a W in your name at index. Oh, I actually said 9. This is actually supposed to be 10th. Right? Because index 9 is really the 10th character. This should be 10th. All right, so this should be an AND because what I'm doing here is I'm making sure that name length is greater than 10. Is that right? Actually, I don't want to be greater than 10. I want to be greater or equal to 10. Okay, if it is, then I'm going to go ahead and check to see what the 9th character is. And then I'll put a W. All right, so I'm going to go ahead and compile this or save it, compile, run. Right, you don't have a W in your name at the 10th spot because it failed right here. It didn't even bother checking right here. But now if I put in 10 characters into my name, so that's 4, 5, 6, 7, 8, 9, and then 10 would be the W. If I were to save this, compile, run, the 10th char in your name is W, right? So what happened this time was this term we evaluated to be true, so then Java was like, okay, well, that's true. I'm going to go ahead and check the 9th character. The 9th character, W, that returned to true, so then I was able to print this out. The 9th character, your name is a W, right? Pretty cool, right? You can now check all your friends' names to see if they have a capital W in the 10th spot. I don't know. I think that's pretty cool. I would be impressed if somebody showed that to me. Yeah. So that's how you short circuit, okay? All right, so let's hop over to the next thing, which is the if statement. All right, so we've already been using it, so it shouldn't be too complicated. All right, the if statement. So now let's look at the if statement in more detail. The if statement has the following syntax. So you have the if reserve word. You see where it's pointing to the if. Then you have some condition, which is a Boolean expression. And then you have the statement that's executed. So one of the things that you'll notice is that there's no curly braces. So you don't necessarily need the curly braces. If you don't put the curly brace, though, that just means you're only going to execute one statement. But if you're going to execute more statements dependent on that condition, then you need to put the curly braces in order to like make a block statement, right? Like you have like a group of statements you want to execute. Now, most places that I've worked at, in fact, all the places I've worked at, have always enforced always putting curly braces, even if you only have one statement, right? Because I only had one statement here, I don't need this. And because I only have one statement here, I don't need that, right? But it's just better programming practice to have the curly braces all the time in case you ever decide to go back and add the curly braces in later, right? You can see that it ran just the same. All right, and now we have a diagram of how the flow of control is actually working. So you come into your if statement, the condition is going to be evaluated. If the condition is true, you're going to execute the statement. If the condition is false, you're going to bypass the statement. Right? You're not even going to execute it. Indentation. So the statement controlled by the if statement is indented to indicate a relationship. The use of consistent indentation style makes a program easier to read and understand. The compiler ignores indentation, which may lead to errors if indentation is not correct. Okay, so basically what they're saying is, right, by indenting inside of my if statement, I'm actually showing that the statement here belongs to my if, right? But you don't necessarily need to indent. You can just have it like that. right? You can even have it like that, and this statement can be over here, and then this can be like, right? Because the compiler is basically going to parse out all the reserved words and symbols and create the bytecode, and all this white space is ignored. But you see how it makes this kind of really difficult to read, to see what's going on? But if I were to save this, compile, right, it did compile, right, and then run, it works just the same. All right, so you have to be careful with that. Indentation makes things easier to read. That's why whenever I look at you guys' code, I always tell you, like, hey, you need to indent this, you need to indent, because it's just good programming practice to just get used to indenting things, right? So inside of your class header, so here's my class header right here. Your methods or anything inside of your class should be indented one level, right? And then here's your method header. Anything inside of your method header should be indented one level from your method header, right? So the method header was indented one level, and then its statements are indented one level, right? So there's two levels of indentation from this programming statement to the class header. But then when you get inside of your if, you indent your statements associated with your if one level, right? And that statement is indented from the method header 2 levels, right? And then from the class it's 3, right? So you just indent to kind of show ownership of where that statement belongs to, right? So this statement's attached to the if, it's indented one level. This if statement is attached to this method header, so it's indented one level from the method header, and then this method header is attached to this class, so it's indented one level. The curly braces will align with, dang, who did it? Oh wait, I messed this up on purpose. The curly brace here aligns with the header of whoever is closing it, right? So this is the method header, that's the open curly brace, and the closing one will align with the P on that header. This is the closing curly brace for the class. It's at the same level of the start of the header for your class. Any questions on that? No? All right, so keep indenting. Let me fix this before I move on. All right, and it just what it does for us, it just makes the code easier to read. Like, you can kind of look through this code and kind of just look and see what's going on just by looking at the indentation. And they have this quote here, which is, it makes sense, but always code as if the person who ends up maintaining your code will be a violent psychopath who knows where you live. Martin Goding, okay? And it's true. A lot of times as your first programming job, they're gonna tell you, like, oh, just go, there's a bug in this code, go find out where it's at and add, fix what's wrong or something, right? So you're looking at other people's code, and like, if they didn't put enough coding statements in there, so you might not know what's going on. If they had poor indentation, which normally at good companies that wouldn't happen because a lot of your code will go through a code review. So things like indentation won't be a problem, but using good programming practices makes the code easier to read. Right? Like, one of my big things that I don't like is I don't like my variables to be something that doesn't make sense for what it's supposed to be doing, right? So if you know, like, this name variable is going to hold the user's name, then it should have name in there and not like an R or just something that doesn't make sense, right? So I've had to do maintenance on code where somebody just used one character variables for everything, right? And it didn't really give any context to what the variable should actually be doing. But in some cases it's okay. Like, if you're just using a variable to kind of count the number of executions in a loop, like we did for the for loop, where you use like int x or int I, then at those situations it's kind of expected. But if the variable actually contains some type of data, you want to give it a name so that when you look at that name, you can immediately know what that variable is actually supposed to hold. All right, so quick check. What do the following programming statements do? So the first one is, if total does not equal whatever we have in the stock plus the warehouse, then there's an inventory error, right? That makes sense. So basically total, they want the total to be the sum of stock in warehouse. If it's not, then they set a Boolean variable to true that keeps track if there's an inventory error. And then this next one, found or done. Okay, so if found is true or not done, not done is true, which makes done false, then you're going to print OK. All right, so here it says set the Boolean variable to true if total is not equal to the sum of stock in warehouse. Prints OK if found is true or done is false. The if-else statement, an else clause can be added to an if statement to make an if statement. So we've already talked about this, but essentially if this condition is not true, then you can execute this statement, which would just, if this evaluates the false, then this statement will be executed. So the condition is true, statement 1 is executed. If the condition is false, statement 2 is executed, or the other will be executed, but not both. Okay, and they give you an example. You can look through that if you want. Wages.java. Then here is a flowchart of the if-else. So you evaluate a condition. If the condition is true, you execute statement 1. If it's false, then you execute statement 2, and then you continue on with the code. The coin class. Okay, so let's look at an example that uses a class that represents a coin that can be flipped. Instance data is used to indicate which face, heads or tails, is currently showing. All right, let's look at this. All right, so this is their driver class because it has the main method. They instantiate a coin object, they flip it, and then they're trying to see if the coin is heads, you win. If it's tails, better luck next time. All right, pretty simple. Then their class for, well, that was their driver class. And then they do a run of it. Okay, every time you run it, it's going to be something different. Right, then here is their class for the coin object. They define heads to be 0, tails to be 1, and face to be an integer. In their constructor, they call flip. And then in flip, you just take math.random times it to 2, and then cast it to an int. That's going to give you 0 or 1. And then they have a Boolean, or they have a method that returns a Boolean value, and it basically checks to see if the face is equal to heads. If it is, then it's going to return true. If it's not, it's going to return false. And then they have a toString method. All right, so yeah, they just basically use the if to tell you if you won or not by checking if its heads are true. Right, they invoke this method is heads, and that's going to hop down over to here and check to see if the face of the coin is equal to heads, which is a 0. And if that's so, it's going to return a true. And then their toString simply just returns a string, heads or tails, depending on if the face is equal to heads or not. Okay, pretty simple. And then indentation revisited. Okay, so remember that indentation is for the human reader and is ignored by the compiler. So if you have an if statement, an if-else statement where depth is greater than or equal to upper limit, and you're setting delta equal to 100, and then your else case, system out print line, resetting data, and then delta is set equal to 0. Okay, so despite of what the indentation does, right, the else, because they didn't use a curly brace, this is the only statement being captured by the else, meaning only one of these two statements are going to be executed, right? But they have it indented like if they want both of these statements to be executed on the else condition, right? So if this is false up here, then they want both of these to be executed if the condition is false. Unfortunately, they didn't use the curly braces, so Java is going to only attach this line of code to my else, or to this else, and it's going to execute this delta equal to 0 all the time. It's almost like if this delta 0 is like right here, right? It's just like some line of code that is executed after that if clause is complete, right? So they're kind of showing you a problem with not using curly braces. Despite what the indentation implies, delta would be set to 0 no matter what. And then it hops into talking about block statements. Several statements can be grouped together into a block statement delimited by curly braces. The block statement can be used wherever a statement is called in the Java syntax rules. So here they're saying if total is greater than max, then they're putting their curly braces. Now I've gotten in the habit, just because of the coding standard we have at where I work at, of putting my curly brace on the same level as the clause here, right, of the if. But it's okay if you do it like that as well. Maybe that's easier to read. I don't know. Some students prefer it like that. I actually preferred it like that at one time, but it's just out of habit now because where I work at, the program or our coding standards has us put the else right after this curly brace and this curly brace on the same line as the if header, right? Just to save line space. I just got used to writing it like that. But either one is fine. They both work the same. So if you choose to put the curly braces like the opening right underneath the if, and then close on its own line, then I'm okay with that. All right. The if clause or the else clause or both could govern block statements. So they're just basically saying, if you want to execute multiple lines of code, you just use these curly braces, and now both of these statements are attached to this if condition. If this is false, then using curly braces here, you're attaching both of these statements to the else. I'll give you an example. Pretty simple. Nested if statements. The statement executed as a result of an if or an else clause could be another if statement. These are called nested if statements. The else clause is matched to the last unmatched if no matter what the indentation implies. Braces can be used to specify the if statement to which an else clause belongs. Okay, so I know that doesn't make any sense, but I have to do an example to prove what they mean, what they're talking about here. So they're basically saying, let me just do a fresh example. All right, so I don't know what to name this, but I'll call this one nest example. Okay, so what I want to do, actually, let me finish. I don't know why I didn't add in that. All right. So I'm going to kind of do the same example that I had before, maybe like with the num1 is equal to like 10, and then string name is equal to Mike. All right, so first thing I'm going to check to see is if name is the length of my name is greater than, I don't know, 2. Okay, if that is true, then I'm going to check to see if my name at char at 1 is equal to an I or an uppercase I. All right. Then what I'm going to do is I'm going to say system.out.println second letter is an I. All right. All right, and then the else, I'll just say something like system.out.println second letter is not an I. All right. So let's look at what I did here. Okay, so I didn't use any curly braces, so I'm just making it like super confusing to everybody of what's actually happening. All right, so here's my if, okay? So according to the rules of Java, right, the next statement after the if is what's going to be executed if that condition is true. So then this is what's going to be executed if this is true. Okay? Then if this is true, then this is going to be executed. Okay, now the question is, when is this else going to be executed? Right? Is it going to be executed if this is false, or is it going to be executed if this is false? Okay, I indented it like if this is attached to this, right? Okay, so let's just run it and let's just see what happens. All right. So, yes.
You're missing your curly braces.
Oh, you don't need your curly braces?
Oh, really?
Yeah. So I purposely left them out to kind of show this problem. All right. So the first time it's going to execute OK, right? I'm not going to see any problem because, in fact, my second letter, right? Second letter is an I, so it only made it to right here. But if I change this to a E, compile, run, second letter is not an I. Okay. So it worked exactly how I expected it to work. Okay. Or exactly how I indented it. And the reason why is because this else is going to be attached to over here. Now, if I didn't know any better, I would maybe just say like if, and then come over here and then say your name is, let's see, your name must be at least 2 chars. Okay. Now, when I write it like this, right, I'm expecting this else to be attached over here, right? But white space is always ignored in Java. So when I make my name like 1 character, then I compile. Actually, it should have been like equals to, right? I don't know. I messed that up. But all right. So compile, run, and it didn't output anything. Okay. Now, the reason why I didn't output anything is because this failed here, okay? That became false. So since that became false, Java's going to look for the if that's attached to it, but it doesn't see, or excuse me, it's going to look for the else attached to it, but it doesn't see an else attached to this if because it's attaching this else still to that if. Does that make sense? Right? So this is like you can run into a lot of problems when you don't use your curly braces, right? So you can avoid this problem by putting the curly braces here and closing it off like that. And then now Java will know like, okay, well, I'm only going to execute this part of the if for this if right here. Now when I compile, when I run, it says your name must be at least 2 characters. All right. But when it's not there, then this else is still attached to that if. All right, makes sense? All right, so that is it for the next section, or for this section. So the next topic is comparing data. I'm going to go ahead and stop there and give you guys a quiz to do. Okay, so this is what we're going to do. And I'll kind of just start it for you because I can kind of show you what I am expecting. So I'm going to make a new file. I'm going to save this one as, what do you call it? Chinese year, I guess. I don't know. Something like that. All right. So what we're going to do is we're going to ask the user for a year, and we're going to tell them like it's the year of the pig or like all that nonsense, right? So I'm going to say import Java. It's not Java. That's Java. Java.util.scanner. I'm going to say public class, and then I'm going to do, wait, that's not what I wanted to paste. Dang it. I didn't copy. Chinese year. I'm going to say public, God dang it, public static void main string array arguments. All right, so what we're going to do is we're going to make a scanner, right? We know how to do all this already, or you should know how to do this all already. And then we're going to just have a variable for the year the user inputs. So we'll have an int for year, and then we're going to ask the user system.out.print. Enter a year. Yeah, enter a year. Okay. And then we're going to store the year by saying scan.next int. All right, so all that is this stuff that you should already know how to do. And now what we're going to do is we're going to print out the year. I don't know. What do you call it? Is like the animal year or something like that. So, I don't know.
Zodiac?
Yeah, zodiac. That's what it's called. Dang it. Chinese zodiac. All right, Chinese. Does anybody know how it's done? No, you guys don't remember all this kind of stuff? No? All right. So what we're going to do is you have to use a bunch of if statements, okay? So the first thing I want you to do, and I'll type up the quiz, is we're going to have to give the user an error if he goes out of range, right? So first thing we're going to check is check if year is in range. And I don't know what the range is, but I was actually looking this up, right? This is my first time ever giving this quiz. Sometimes I'm like, I got to change things up. It's been like 10 years that I've been using the same quizzes. So if you're less than 1924 and if you're greater than 2013, then what we're going to do is, that's 2031. Then we're just going to say like invalid year, even though you can probably keep doing the calculation past 2031. Well, let's just say that we want the year in the range of 1924 and 2031. So you're going to check to see if it's in the range of 1924 through 2031. Anything outside of the range is going to be invalid. So you can do like a positive check, right? You can just say, okay, well, if the year that they gave me is greater than or equal to 1924, and the year that they gave me is less than or equal to 2031, then you can continue processing, right? Meaning you can keep trying to like figure out if they're a dog, cat, mouse, moose. I don't know, what else is there? Wait, there is no moose, right? Rooster, dog, pig, right? You can figure out if there are any of these, okay? So the calculation for that, we'll talk about the calculation, but it's pretty simple, right? We just take the year minus 1924, okay? It's just the year minus 1924, divide by what? Anybody know what you can divide by? Take it, there's 12. So if it's 0, actually, hold on, let me think about this. We don't want to do 1924. We want to do 1923. Hold on, let me think about this really quick. I have to look at this and figure out what the math equation is going to be. Okay, so the route would be like a 1. This would be a 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you divide by 12 and you get a 0, that means you're a pig. But if you divide by 12 and you get a 1, like your remainder is 1, then you're a rat. Does that make sense? So we actually want to subtract 1923, and then we're going to have to use the modulus divided by 12, and then whatever the remainder is, right? So you're going to like just save off this remainder somewhere. You're going to say like, okay, well, the remainder is equal to some calculation, right? The year minus 1923 divided by 12. And if it's a 1, you tell them they're a rat. If it's a 2, they're an ox. 3, tiger, right? Does it make sense? You basically have to do a calculation to figure out, because every 12 years it changes, right? So the first time it's a rat, second time it's an ox, and then so on and so on. Yes? Right. So the first thing we're going to check is, so you're only going to process it if they have a valid year, right? The else case would be that year is out of range. Or you can actually be a little more interactive with them. You can just actually give them the year they entered. Like you can just say something like a year. Right, so like if they entered is out of range, and then maybe up here to kind of help guide the user, you can give them a range up here, 1924 through 2031. Okay, so let me go ahead and save this, and I'm going to compile and run. Right, enter a year, and if I were to enter in 1200, right, 1200 is out of range. I run it again. Wait, Control 2 to run again. Zoom in, and if I enter in 2050, right, the year is out of range. If I run this again, but this time I give it a valid year like 1950, it doesn't do anything because it came into here and I hadn't finished my processing yet, right? So what I want you to do is tell, if they enter in between 1924 and 2031, bark back to the user like if they're a pig, a rat, moose, hamster, right? By using that calculation. Does that make sense? It's just a math equation. You're gonna like whatever year they enter, you're gonna subtract 1923, and then whatever value is left, you're going to divide it by 12, and then when you divide it by 12, whatever your remainder is going to be what you output, what they are, right? So if the remainder is 1, they're a rat. If the remainder is 2, they're an ox, I think it was. If the remainder is 3, they're a tiger, right? If the remainder is 0, then they're going to be a pig, right? A dog would be 11, and then a pig would be a 0, because a pig is the 12th year. So once you divide pig or your remainder by 12, yeah, it would be a pig. Does that make sense? All right, yeah, I know it seems complicated, but if you think this is complicated, just wait till you see the homework I give you, okay? So I'm going to go ahead and work on getting you guys the homework this weekend so you can start. It's going to be problems from the book, but I'm actually going to have you change things. Like, it's not going to be just the straight problem straight from the book. I'm going to have you redesign everything to make it more object-oriented friendly, or I might have you just make utility methods, right? I'm going to be kind of very specific about what I want you to do. It's not just going to be, hey, copy the question from the book, Google it, and then, copy and paste whatever you find on Google, right? It's going to be like me telling you, this is exactly what I want you to do. I'm going to give you, I'm going to tell you exactly how I want you to do the problem. All right, does it make sense? All right, so that is your quiz. I want it done by 8 o'clock or it's 0. I'm just kidding. Now, you can take it home and work on it, but try to get it done. I'll probably sit down and grade it this weekend when I grade your guys' test corrections, okay? But I do want you to actually do this between now and then, right? Like, don't let the time go by without actually looking at this kind of stuff, okay? Because I'm serious. Like, chapter 4 is like a huge hump, right? But then students get super confused in chapters 5 and 6 because now they got to start thinking like, okay, we're not linear anymore. I need a condition to go this way and one to go that way, and right, it gets a little hectic, right? But it really isn't that bad once you just get used to using these things, right? So you need to know how to use the if and the else, right? And I do want you to use the if and the else for this. Don't go looking up the switch or anything like that, or Googling questions or whatever, just so you can paste something in here. Like, I want you to stick with using the if and the else, or the else if, okay?